Today, you need these 2 pages, okay? Your cards and your template. We're going to be putting this on page 31, all about optics. Okay? We have wave behavior, an example, and we have the definition itself, okay? So you need these. And of course, your science notebook, scissors, and glue. Okay? So we're going to go ahead and we're going to cut these out.
I'm late. What do we cut out?
We're going to go ahead and cut out these cards. I'm going to cut out each individual card. Recycling our scraps. We're going to cut out around the outside of this template, only around the outside. So we've got our cards sorted into our 3 piles, our definitions, our illustrations, and our examples. Then what we are going to do is on page 32, we're going to title that optics. And then we're going to leave a bunch of room here at the top because we're going to define what optics is. And then we're going to glue down our template towards the bottom of the page.
Mr.
Yes, sir?
That one is got like a gray cube. That one goes with the illustration, right?
Yeah, these.
Yeah, okay. Yeah,
those are the examples.
Okay. Thank you.
Yep. Optics is, use our giant pencil again today. The science and study of, this is one of the ones that doesn't end in ology. Okay, this is the science and study of how light behaves. We talked about how waves behave. We talked about that wave behavior. Light also has a specific set of behaviors, and one of the reasons is because a photon, okay, a particle of light, acts both as a wave and as a physical thing. So it has a couple more ways that it interacts with the world, and that's because it has that particle duality, that dual nature of being a wave and a physical particle. Okay, so when we look at our 3 different behaviors, we have transparent, translucent, and opaque. This describes a physical object. This describes the barrier, okay? And light is going to pass through the barrier a specific way, okay? So transparent, translucent, and opaque, this describes the barrier. Has anybody heard any of these words before? I know some of you have done this homework already, and you've gotten some pretty good grades on it.
I've done it. I've heard the words, I haven't done the homework yet.
Okay, you've heard the words, haven't done the homework yet.
I
So
did everything from that packet.
Perfect. So in your experience, Annie or Mr. Jones, what is something that is transparent, a barrier that the wave is going to have to behave around? What is a transparent barrier?
Glass.
Okay. What kind of glass? Any glass? All glass?
I think.
Okay. So is a red glass going to be transparent?
No.
No, it's not. So that's an interesting thought. So when we look at our definitions here, we have a material or substance that allows all light to pass through. We have a material or a substance that allows some light to pass through. And we have a material or a substance that allows no light to pass through. Okay, so we'll call it C, B, and A. Which one of these is going to best fit the material that you've heard as transparent?
I think I know.
You think you know? What do you think it is? Is it A, B, or C?
And we're doing transparent, right?
Transparent. That's correct.
A.
A. Yeah, it's going to be all light. All light is going to be able to pass through a transparent barrier. Okay. And again, the word transparent describes the barrier. It doesn't describe the light itself. Okay. So a transparent barrier is going to allow all light to pass through. So Annie, if we're thinking back to glass, what color glass is going to let all light pass through it, in theory?
Clear glass.
Yeah, clear glass. So if we're thinking about the red glass, because I asked you, what about red glass?
Yeah.
Is red glass going to be some light or no light, do you think?
Some. Because
Some.
it's still kind of clear.
Right, because there is still some light coming through it, like a stained glass window.
Yeah.
So when we're thinking about this some light, is it going to go under opaque or translucent?
Translucent.
Yeah, it is actually going to go under translucent, which means opaque objects, those are the solid objects that let no light pass through. Okay? So let's glue our definitions down in the correct place. A, B, and C across the board. Yes, sir. What's your question?
Why did you say it was Revenge on 5th grade today?
Revenge of the 5th.
Oh, the 5th.
Yeah, Revenge of the 5th. It's another Star Wars pun. Because yesterday was May the 4th be with you instead of the Force. And then you have Revenge of the Sith, but it's the 5th.
Oh.
Yeah, no, not Revenge on 5th grade. Just Revenge of the 5th.
I don't watch I've never watched a Star Wars movie in my life, so I don't know.
You should. They're good movies. It's space opera.
Mr. It should have been The Fifth Strikes Back, because that's actually a name of one of the Star Wars movies. The
That's
Sith
fair.
Strikes Back.
That's fair. Emily and Allison, you guys have a question?
Where did this last one go?
Okay. Well, maybe you can answer for us. So we have our illustration cards here. Okay. We have our illustration cards here. Let me make it so that we can see our definitions.
No, it did not go.
Okay.
Where did it go?
There we go. If we're talking about an opaque object, okay? If we're talking about an opaque object, see, which one of these illustrations is going to best reflect what an opaque object is? A, B, or C?
I think I know again, maybe.
C?
C.
Yes. Yes, Emily and Allison, it is C. Now, does this always have to be a solid object?
No.
No, it doesn't. No, it does not. And we often get stuck in this idea that all solid objects are opaque. Okay? Is glass a solid object, Oak?
Hey, Miss Sterrett.
What's up, Furman?
I have to
Yes.
go.
Okay, honey.
Bye.
Goodbye. Oakley, glass a solid object? What do you think?
Yeah.
Yes, it is. Now, if we're talking about clear glass, which is a solid object, okay, which of the illustrations, A or B, is going to best represent clear glass? Which of those illustrations is going to best represent clear glass, that nice solid object? Grace?
B.
B. B is going to represent that clear glass. So now we need to figure out, is B going to go under transparent or translucent? Clear glass. Is it all or is it some? Mackenzie, what do you think? Yes, it is all. It is all. So we are going to put that under transparent. Okay. Now, are all barriers solid objects? Do all barriers to light have to be solid objects?
No.
No. Chlorine gas is actually a bright, vivid green color. It's a bright, vivid green color. So do you think it's going to bounce back some of that green light and let all the other light pass through it if it's a gas? Think about what you learned about how colors are created in 3rd grade, how we see color.
It's gonna with that chlorine gas. It's going. It's not gonna go directly through.
Mm-hmm.
I mean, it's gonna stop once it hits a barrier.
Mm-hmm.
But when you got your cracks, and that's not a solid object.
That's right. It's not a solid object.
It can go through water, even though it does. Even though that's what they used during the First World War, it turned everything different colors, but it didn't stop it.
So light, as far as we're concerned, just talking, because you're right, but as far as we're talking about for just light, okay, this part that's bouncing back, that would be our green light waves. That would be why the chlorine gas appears to be green. It's going to be those red and blue, those green light waves. All the other light waves, the red and the purple, that's going to pass right through it. So we're not going to see that part of it. We're only seeing the part that's bouncing back. Okay.
Another gas that you'd see, I forget.
There's a bunch that you could see. Most of them are clear though.
Yeah.
Okay.
Tear
So then-
gas, like a cloud.
Agent Orange. Okay, looking at our examples then, we've got 3 sheets of glass or plastic in front of an apple. Which one is translucent? Type it in the chat what you think. A, B, or C. Which one is going to be translucent? Remember, we're looking at all for translucent, or I'm sorry, for transparent, some for translucent, or no for opaque. Is it A, B, or C for translucent? See a lot of B's and a lot of C's, some A's. is C. It is C. Because if we look carefully at this picture, we can see that it's a little bit grayed out. Clearly there's a barrier there, okay? And we can also see that the lines are not as sharp, which means that only some light is gonna come through. We've only got some of that light that's allowing us to see the apple through the plastic or glass, okay? So then we're looking for all or some, I'm sorry, all or no. Which one is going to have no light pass through? Which painfully obvious one?
B.
Yes, it is B. So B is going to be our example of that opaque object. It's like trying to look at an apple through an icy pop. It's just not going to work. Which means A is our example for transparent. Now, let's talk about transparent here because we're often going to see clear glass as an excellent example for something that is transparent. Okay? Clear glass, that's the impression that we are under. Okay, think Mike's tank, Luigi's tank, Bob's tank, okay? The windows in your house, clear glass windows on any cupboards. Okay, this idea of a clear glass. Is clear glass perfectly transparent? Does it allow 100% light to travel through it? See lots of head shakes, lots of people who are tentatively saying no, but you don't want to quite be wrong. What is some evidence that clear glass is not perfectly transparent? What piece of evidence is there?
Miss Starrett,
Yes, sir.
what about like, you know, your
Ants can be
window
stuck on
tint?
it.
One more time, Mr. Jones.
Your window tint, like on your cars?
Yes. Well, that would be translucent, wouldn't it?
Yes.
Yes, because it's tinted. Yeah?
Yeah.
Okay. So we're thinking perfectly clear glass, nothing that's tinted, or something that is supposed to be perfectly clear. Kylie, what do you think?
If it's like a really, really sunny day out and I'm trying to look through the house window or something
Mm-hmm.
and I'm outside, I can't perfectly see through there.
Right. What can
Because
you
the
see?
glare.
Well, there is a glare, but what can you see in the window?
You can see dark shadows.
You can see dark shadows. Can you see your own reflection?
Yeah.
Yeah.
Hey,
Because of the light bouncing off the window.
exactly. So if we look at our image for opaque,
Unmuted.
what image
muted.
does this look a lot like? If we think back to our wave behavior, think back to wave behavior. What does this image look like? Reflection, refraction, diffraction, interference.
Refraction.
Good guess, not quite refraction. That would be bending of a light wave.
It's reflection.
It's reflection.
Refraction?
This looks a lot like bouncing, doesn't it?
Yeah.
Yeah. So don't get confused, ladies and gentlemen, okay? Remember what I said. A wave, a photon, okay? A light wave acts both as a particle, like a solid object, a ball, and it acts as a wave, okay? A wave can be absorbed, okay? Or a wave can bounce, or it can bend. But that particle piece, it's going to bounce off. It's going to change direction. It's going to change speed. And this is what makes light behavior a whole field of scientific study, because there's so many things about it that we can kind of noodle out and figure out, because it behaves as a particle, a physical object, and a wave. So when you are thinking about this, when you're thinking about, oh, is it opaque? Even though that image looks a lot like reflection, it is not reflection. Reflection is a wave behavior. Opaque describes the barrier, okay? Opaque describes the barrier. It's not describing what the light is doing. Yes? Does that make sense? Is that clear? Okay.
Yes.
The barrier is opaque, so light waves cannot travel through it. Our example looks like reflection, but it is not reflection. Okay? Now, really quick before we go, just really quick, really quick, we're not going to put this in our science notebook because we really don't need to. I trust that most of you know what this is, okay, that you understand how shadows work, but I want to talk to you about them regardless. Okay? This is a lamp. That's a wall. Let's call it a Lego wall. This lamp is on. There is light shining out of the top of it. Is the light gonna pass through this Lego wall? I see head shakes. What do we describe this barrier as if light is not gonna pass through it?
Solid.
It can be solid, that's true.
Opaque.
Opaque. It is an opaque solid, okay? So if it's an opaque solid, what's gonna be on the other side of this wall?
Nothing. A shadow.
A shadow!
Darkness.
Darkness. Boom, there's a shadow. Okay? Now, one of the reasons why we draw shadows like this is because, of course, light is also going to diffract around our opaque solid. The light can bend around. But for the most part, we have a nice solid shadow. Okay? And if I change my lamp to the other side, is my shadow going to be on the other side? Am I going to draw my shadow over here by the lamp?
Yes.
No, that would be silly. Boom. My opaque solid is here. My light is here, being all shiny and bright. Boom, shadow on the other side.
Miss Derek,
Yes, sir?
can you show me the title of the page in the science notebook?
I will indeed. All right, so as long as you know how shadows work, that is it for class. You are welcome to leave. If you have any questions, please let me know.